Good afternoon and welcome to ETAuto EV Summit 2022. The era of EVs brings with it widespread disruption, but it also opens a gamut of opportunities. One of the aspects that is relatively less talked about is jobs, both the number and the nature of them. With the engine replaced by a battery, the vehicle becomes simpler, but it also rides on software like never before, heralding the age of smart jobs in domestic automotive industry. But to fully exploit the potential, a different mindset is required, and the workforce needs to be trained and skilled differently. Over the next half an hour in this panel discussion, we will be talking about the different facets of how the industry is gearing up to equip the workforce with the right kind of skill sets for the EV revolution and the close collaboration that is taking place between the industry and the academia. I'm joined by Dr. Shankar Venugopal, Vice President, Mahindra and Mahindra, and Dr. Anandkumar, Director, Curriculum and Applications at Skill-Lync. Let me start off with you, Dr. Shankar. We know that EVs bring with it a lot of new kind of challenges, new skill sets are required. How are you grappling with this? How are you tackling this at Mahindra and Mahindra, being one of the pioneers in EVs and also one of the largest OEMs in the country?
Hi, Sumant. Thanks for bringing up this. This is the most important question that's facing the entire automotive industry, not only in India, but across the globe. And we started this journey almost 5 years back, where we started reskilling all our engineers at the Mahindra Research Valley across the entire gamut of electric mobility. And this primarily is a very large-scale effort, looking at least 3 levels. The fundamental level being the engineering foundation, where we need our design engineers to have engineering skills across at least 4 domains: mechanical, electrical, electronics, and basic programming, computer programming. So it's not sufficient if we have an extremely good mechanical engineer, but he should also have practical working skills across these other 3 domains. So invariably, we end up hiring a mechanical engineer or electronics engineer, and then we reskill them on the job. And that's what, as the Dean of the Mahindra Technical Academy, it's my primary responsibility to continuously reskill all our engineers with the emerging technologies. But that is only the foundation layer. The next layer is the integration layer, where they have to translate all this engineering knowledge into product features that the customers really appreciate. And that's where the skills like the overall integration skills, focus on the needs of the customer, focus on quality, all these things become very important. In fact, these are skills that we can take forward from the current IC engine technology to the electric vehicle technology. Though there is a lot of new things to learn, there are also things that we can always take forward. And then finally, at the topmost layer is innovation, having a growth mindset, getting yourself free of cognitive biases. This becomes very, very important for us to differentiate ourselves from the crowd and make sure that we are able to contribute through innovative ideas through this domain, which is fast growing. So the curiosity, creativity, and innovation is there right at the top. And then in between is the integration skills. And the bottom layer, which is the foundation, is the engineering skills, which cuts across at least 4 distinct engineering domains. So this is the quantum of reskilling that we are really talking about today.
So whenever we talk about a technological disruption, there is always some talk about unlearning some of the other things that you already know, like you mentioned, cognitive biases, etc. While at the same time, you have to acquire new skills. How challenging is it versus some of the other bits? We have seen the dot-com revolution, and that also spawned a lot of new skills. Internet has completely changed our lives. Now in transport, we haven't seen a disruption of this sort ever. And we are unlikely to see something like this, maybe not in this lifetime at least. How much more difficult is this for any average Joe who is working on the shop floor or who is working in an automotive company?
Sure. One of the biggest difficulty is the pace at which all these technologies are growing. There was a time when these were growing incrementally, and so you had sufficient time to learn all these technologies. But now we are at a phase where these are growing exponentially. So you'd be familiar with the Moore's law, where the computing power kept doubling every 18 months. That is true of every digital technology that we touch. Today, we are talking about a vehicle which is electric, smart and connected, comes with at least a second or third level of autonomy. So when we look at all these digital technologies getting into the vehicle, all these are growing exponentially in their performance, and the cost of technology is also falling exponentially. So you have very little time to master these new technologies and apply them in the products that we are building. So that is the toughest part because you don't have a lot of time. You are working, building products at the same time you are learning and applying. That's what makes it really very challenging.
Dr. Amod, I would like to bring you in here because you are basically the bridge between students and the industry. So you are tasked with the onerous responsibility of curating curriculum and syllabus, which is very, very appropriate to what the industry requires. And we are not talking about what industry requires today, but what it might require maybe 5 years or 10 years down the line when electric mobility will really have taken a main stage. How are you dealing with this, and what kind of challenges do you foresee for yourselves?
Yeah, thank you, Sumant. I think Dr. Shankar had a very good, overview here on what are some of the key challenges that you face, especially with employees. One of the things that we are seeing at Skill-Lync is, as students finish their curriculum, the level of readiness to be, immediately employable and active on projects in the industry is actually, a major miss in the current system. And this typically happens because while there is a very strong focus in the academic system for fundamentals, the practice and application of it really gets lost. And the way you can then start approaching this is to understand what are the practices that are happening in the industry today, how are they transforming, and then seeing how you can then bridge that gap. And that's essentially what we've been doing. So let's take an example for that, right? So we talk about mechanical engineers, who have very strong knowledge of how an IC engine may work, and there has been a lot of talk and worry of what would happen to mechanical engineers in the EV revolution, right? I very much feel that there is a strong role for mechanical engineers to continue to play in the EV revolution, but obviously not as IC engine designers, but in various other roles. So this can happen in multiple ways. So for example, when mechanical engineers are graduating today, if they also understand how electronics is integrated into the mechanical systems, and then how software brings all of this together and ultimately is controlling all of this, that really is the key skill that's missing today. You have mechanical engineers who understand the dynamics or the thermodynamics and all of that in very great level of detail, and then you have electronics engineers who understand the circuits and the chips very well, and you have software engineers who know to write great software. But bringing all of these things together is really where the gap is. And that is one of the things that we've been focusing on, creating curricula that actually brings this interdisciplinary nature and focuses on how this specifically applies to electric vehicles. And that has been the primary driver for our curriculum.
Very true. In fact, we never had any tailor-made automotive engineering course in India. We generally tend to either do mechanical engineering, or somebody will do computer science, somebody will do software, and then you fit in wherever. But nothing is very specific to this industry, which is 50% of our manufacturing GDP. So it's quite ironical. I think this is a good time to think back and say, let's design a course which is completely focused on automotive, because like you mentioned, it will have facets of mechanical, electronics, as well as software, because a car will no longer be just a mechanical machine. It will have a lot of things riding on it. One thing that probably works in our favor, or at least that's what we are told, is the demographic dividend that we have in the young workforce, the number of students that we have, and they seem to be much more adaptable to any changes that might be required in course and curriculum. They're more eager to learn and acquire new skill sets. Do you think that works in our favor, and or is it still the age-old dilemma where people tend to resist anything new that you present them on your table?
I think that today's young engineers are really hungry to bring themselves on par with today's and tomorrow's needs. We see a lot of enthusiasm from engineers, in willing to learn new skills, and all they need is really that appropriate guidance of here is what the industry needs today. And that's where a tailor-made curriculum or a tailor-made program that helps bridge that really helps achieve that. We have seen students who might not have performed very well academically, but once you actually bring to them a core learning from the basic mathematics or physics behind, say, how a motor operates, and then teach them how you would solve these simple problems by pen and paper, and then finally bring on the amazing amount of tools and automation that's available in today's engineering practice. On top of all of this, they're able to rapidly pick this up in just a few months. And we've seen thousands of such successes where they transition from a non-automotive career to an automotive career.
Interesting, because history is replete with instances of people who have been toppers or very academically inclined, but not so street smart. They haven't probably done as well, but some street smart guys who have been average, they have gone on to become excellent inventors and entrepreneurs. So, Dr. Shankar, you already have a large workforce of people who are working on the shop floor, engineers, designers, and now they are coming in and trying to do something very, very different. Do you also see these examples where somebody might have been maybe an above average person in his role, and now suddenly in this new area he's doing very, very well because probably he takes it to like a fish to water? Do you also have such instances happening in in your company?
That's absolutely true. I have a lot of evidences for this. See, we hire a lot of young engineers, both at undergraduate and the postgraduate level across the country, and bring them to the Mahindra Technical Academy. This is the organization that I run. And I run a program which is about 3 months long program, which bridges the gap between what they learn in their college versus what they need to know to get started on a real project out here. One thing I observed is during the 4 years or the 6 years in the college, they had enough of lectures. So they don't want any more lectures. They want to do things hands on. So, and that's also a very fast mode of learning. So, what we do is assign them to projects and also assign mentors so that they can learn on the go. They start building something and keep learning on a need basis whatever they need to further move to the next stage. That is something they like because it's very fast paced and it's flexible, and they always have a mentor to go to. And finally, at the end of the day, they have a product which they can test and go around with it. So that gives them a very high level of satisfaction, and students are able to stretch and themselves even they come on the weekends, and because they're so passionate about making it work. So I have seen this even when they are in college. We run this Society of Automotive Engineers, a competition called Baha, where they build a Formula One racing car and then they compete. So colleges across country participate in that. So in the last few years, we introduced e-Baha, which is the electric version of that. So none of these kids had a formal coursework in electric vehicles at the time, but they were able to build a cross-functional team and then build a product and compete in the Baja competition in a very short time. So that gives me the confidence that if we go teach them the right way, which is more hands-on than Gyan and lectures, I think all of them will be able to pick this up and they'll be very happy doing what they are doing. I think we also have to change our ways of teaching. Then it will work very beautifully and it will happen very fast also.
Good that you mentioned Baha, and for any of our listeners and viewers who are probably hearing about this for the first time, I would encourage them to look at the kind of projects that have emanated through Baha over the last so many years. And Mahindra and Maruti, they have been one of the stalwarts in this. That aside, Dr. Shankar, what are the kind of skill sets that you look for an entry level person who is coming into Mahindra, which could be appropriate or viable for EV based jobs? And at the same time, what is the kind of skilling that you are imparting to your existing workforce to be relevant for the future?
So today, when we go for hiring at an undergraduate level, at best we can find a mechanical engineer or an electrical or electronics engineer. It's very difficult to find somebody with a cross-engineering skills. So a lot of it we have to do after they join Mahindra. So we designed a lot of bridge courses, electronics for mechanical engineers and mechanical engineering for electrical engineers. We designed a lot of such bridge courses. And all these are taught by practitioners who are building products. So they come and teach with a product focus in mind so that they'll be able to very quickly move from concept to a practical application and problem solving. But this is one set. The domain knowledge part happens quite easily. It's not that difficult. But what is equally important is we train these young engineers on design thinking, understanding the needs of the customer and defining problems from their perspective. That becomes very important, not only in automotive, but also in the farm space, because we also have the farm product design engineers based at the Mahindra Research Valley. Very few of our students have exposure to farm life, what kind of problems the farmers face. So design thinking has done wonders for us, both in the automotive and the farm space, for the young engineers to understand the real needs of the customers out there. The second is systematic innovation, like a TRIS-based problem solving, where they'll be able to think out of the box and come up with great ideas in a very systematic way. It's no longer a random process. They have a method to go out of the constraints and come up with new ideas. The third is very fast prototyping and testing. So we have created innovation labs and concept development labs at the Mahindra Technical Academy, where students can come, where the young engineers come over there whenever they have a fresh idea. Very quickly, they'll be able to prototype and test. These are scaled down versions of the big labs that we have in the product development function. But these are give all the space and the freedom they need to explore and try out things. That space is very important. So these are the three things: design thinking, and then structured innovation, and then the proto building and testing facilities, which gives them the space to try out many different ideas. I think this has helped us a lot to help engineers to quickly move from the university mode of thinking to a corporate mode of thinking and start getting involved in ongoing product development.
Mhm. Which brings me to the next question of how important will it be to get the right talent? Because I think going forward between manufacturers, there could be a mad race to get that particular person, if you can spot him, who could be perfect fit or could become a perfect fit. But I'll come to that later. I want to ask Dr. Amod that traditional wisdom tells us that be a master of something, be a specialist. And so if you are a mechanical engineer, you stick to mechanical engineering. Don't get into computers or software too much. If you're a civil engineer, just concentrate on building buildings. No need to get into mechanicals. But now this is an era where, like Dr. Shankar was saying, you need to have cross holdings. You need to have a hybrid kind of an education system. Do you foresee, or are you witnessing any kind of resistance to this? Because older wisdom versus new age reality, is there a gap there which you are also trying to plug?
Yes, I mean there are some of these notions that are built in people's mind, especially on what software engineering is from the mechanical engineer's perspective, or what mechanical engineering is from a software engineer's perspective, right? So, for example, a mechanical engineer might think that writing software is mostly just opening an editor and writing pages and pages of code, and it just keeps crashing, and then you keep rewriting it, and so on, right? Whereas the software engineer's view of a mechanical engineer is probably a lot of tinkering and fabrication and welding and all of that. And both of these are really poor understandings of the other domain. The reality of today's engineering is that there is a very strong bridge that actually connects all of these different domains, and that is the role of simulation. So simulation is basically the use of software and mathematical modeling to understand what might happen in the real world before you go and test it out in prototype, right? And actually all of these domains can take advantage of simulation tools, and in that way getting a even a glimpse of what the actual work of the other domain might look like becomes a lot more accessible to students these days. When it comes specifically to the electric vehicle technology, the role of simulation I foresee will be much, much stronger. And the reason is because IC engines had very complex, physics happening within them, right? the combustion, the way fire would propagate, and how the gases would expand, and all of that is very, very complicated to model. On the other hand, modeling a motor, electric circuitry is a much more mature technology, and a relatively simpler physical phenomenon compared to that. So especially with the advent of electric vehicles, I foresee a much greater understanding across domains for each of these engineering disciplines. And I would really wish to see a lot more usage of simulation right from the education system to help people understand how multiple domains come together.
It is fascinating that it is also, in a way, leading to a deeper appreciation and understanding of the other domain. So it's not like a mechanical engineer can look down upon any other forms of engineering, as normally happens in any of these top of the line engineering colleges, that if you are a civil or an electronics or a computer science, then you are in the hierarchy, you are placed somewhere. But now you need to know everything if you want to stay relevant for the future. So that also brings in some amount of cohesion, homogeneity, which is very, very required. I'll go back to you, Dr. Shankar, and ask that question on talent recruiting and then holding on to it. Because if the future is about all these smart workers, there could be a demand supply mismatch. How do you tackle that, or how do you produce enough so that the whole industry can benefit from it?
Uh, I'll come to that point. Before that, I just wanted to add to what Dr. Amod said about simulation being a very powerful tool to quickly ramp up the reskilling part. I fully agree with him. And in fact, we have one of the biggest modeling and simulation group, and that greatly helps us to get a lot of practitioners to come and teach courses based on simulation. Just want to add one more technology to that, which is the AR and VR. So when we bring AR and VR to trainings, it's going to take the whole training to the next level. For example, with electric vehicles, we have few subsystems which are high voltage subsystems. So to handle those subsystems, the people have to be trained and certified. But to be trained and certified, they need to handle it. So this is a catch-22 situation. How do we really give them the exposure so that they are comfortable handling high voltage, taking all the precautions? This is where AR, VR comes to help. So we have designed a training on electric vehicles from safety perspective, which is entirely on AR, VR. So virtually they do all the dismantling and assembly so that they become very comfortable doing it, and then it's easy to give them the actual hands-on exposure. So there are places where AR, VR can greatly accelerate the learning. And a lot of the young engineers seem to like it, actually. Once you put on a headphone like this and start doing something, they really find it very exciting. Yeah. Now coming to your point, how do we basically scale up this entire system of preparing the students for the growing needs of the industry? This is possible only if the industry and academia work together very closely. And this is not just about training students, this is also about training the faculties. So, in fact, I spend a lot of time working with the faculties from various institutes, giving them the exposure to industry practices so that if one faculty picks this up, he'll be able to pass it on to maybe 100 or 200 students. That amplification factor is there. So we started with bringing the faculty members to our place and immerse them in ongoing projects and show them the industry practices. So we call it as micro and mini sabbaticals. Instead of 6 months and 12 months, we do it in few weeks, 4 weeks and 8 weeks maximum. But this gives them a feel for how it is being done in the industry. That is one aspect. Second aspect is to start it early on. So instead of waiting for the final year, if we can start working with the students right from the first year onwards and spread out all the trainings that they need across the 4 years, then by the time they complete the 4 year program itself, they would be sufficiently familiar with the various industry practices and skills. And all these 4 years, every summer, they have to come to the industry and at least spend 1 or 2 months working on an internship. And the internship project should be continue over the 4 years so that they'll be able to take up a problem and solve it end to end. So that means 2 years in the first year, 2 months in the first year, like that every year, 2 months. So 8 months is significant time to do a good quality work, which could even be publishable. And the industry also gets to know the candidate well, what are his or her real strengths. So I think an extended interaction spread over the 4 years is one thing. The second thing is training of the faculties by industry experts. These two, I think, will greatly help us to quickly scale up the entire preparation of industry ready students.
Right. Dr. Amod, this is not something new that Dr. Shankar is talking about. We have been talking about this, that a greater, in a way, collaboration between academia and industry for the longest time. And we know the kind of unemployment problem that we have in the country today. Most of it is not because there are no jobs, but the kind of jobs that are there are very little, very few who can directly fit into that. And going forward, with this disruption coming in, probably this will only exaggerate going forward. How do you bridge that? How do you make your course tailor-made? What kind of discussions do you have with the industry? If you can throw some light, because you are designing the courses like that. What are the kind of inputs that you take from the industry? Any collaborations that you have? If you can throw some light on that.
Yeah. I mean, here is where that active conversation that happens on both ends is really critical. In our role, we spend a lot of time talking to all the large automotive, companies within India, ranging from the OEMs, that is the vehicle manufacturers, through to the component manufacturers and the engineering services companies who provide a large workforce that support both of these segments of the industry. We've worked with a number of such companies to really understand what are the common skills that they need across a large part of the workforce, and then what would be some specialized skills that would be needed for individual areas. So one such example that we recently worked with Cyient, who, as you may know, is a very prominent engineering services company who support engineering across automotive, aviation, medical, and other areas. So in our conversations with them, we understood that embedded software design is a very critical skill that is common across all of these industries, and they all share a common thread through them, which is that bugs or errors in the code cannot be tolerated. Your braking system cannot have a buggy code. Your aircraft control system cannot have any faults in them. Your ventilator software cannot have any bugs in them, right? So that's where our conversations with the industry helps us find such common threads, and then we are able to design highly skill oriented curriculum which can then be leveraged across a wide variety of jobs and roles in the industry. So yeah.
Is the education fraternity, the system, doing enough of this kind of bridging, or is there a need to really accelerate this and catalyze this a little bit more?
Yeah, in some ways, the education system is very oriented towards creating engineers of a very specific mold. And while there is still a need for such engineers, there is also this need for a highly interdisciplinary engineer. And that is where the curriculum today does not offer flexibility to universities to actually go and change this. There are a lot of regulations and rules that prevent creating highly customized or very rapidly changing curricula. And that is where I feel that we need to have a transformative change in how curriculum is designed, and we need to get to the point where there are micro learning modules where you learn small bits of concepts and skills that are spread across a wide variety of fields, and each engineer basically then becomes a very unique individual who then could offer a lot of value to the industry with their specific skill sets.
Right. So Dr. Shankar, I'll go back to the conversation we were having before the panel started, is that the fear that anything new that comes in, jobs will be lost. There have been a lot of things in the past, a lot of phenomena in the past where we have shown that that is not entirely true. Instead, jobs actually increase whenever there is a more efficient system that comes into place. How do you look at this? Do you think because there is no engine, because the vehicles are simpler, that there could be a reduction in the number of jobs? Or do you also think, like in the past, that the number of jobs will actually go up with the electric mobility era?
Sure. So I believe that actually the number of jobs will go up very significantly, but those jobs don't exist today. There'll be all very new types of jobs. So we have to understand what skills we would need to get those jobs and start preparing right away. Okay. So that becomes the very first thing. So that next translates to what is it? And if you look at various skills that we need to learn to pick those jobs, okay, we have some visibility of that. We talked about cross functional engineering skills and then integration skills and customer focus and so on. But that's not the end of the game. That's only the beginning. New technologies are going to constantly come. We talked about exponential growth and also convergence of multiple technologies. So the most important skill that we need to have is learnability. Ability to learn on the go a lot of new things as they keep coming into the domain. So how do we really have this beginner's mindset where I'm not an expert, there are people who know more than me. How can I quickly learn from them and work together and bring all these things together to translate that into something that the customer would see value in? That becomes the most critical skill. So learnability and translation of all this knowledge into features in the product that customers see value. These two things are the most essential skills moving forward.
So it's a very difficult thought that yes, once you are out of the university, you think that at least the lectures will end. But yes,
True.
there may not be lectures, but you're a student for life.
So my own example, I got into the industry after my PhD. So, but I felt the need for a MBA after a few years in the industry. So it's not often that a person with a PhD background goes for MBA, but I felt the need and I went ahead and did a MBA. That actually changed my perspective and also changed my career trajectory itself soon after that. So it went on for some more time. And then, much more recently, I felt the need for going back to school and learning all about AI and data science. So I'm doing that. So after this, from 7 onwards, I have my class, I attend, I have to do assignments, I have to do this and that. So I think there is no end to this. Constantly, we keep doing this all the time. I think that's what keeps us going. And it's also interesting to always learn something new. I think that mindset would be very critical for success. Sure.
I think as scholars, both of you probably are in so love with learning that you cannot let go of it. So probably which is why you're looking for an excuse to go back to a classroom some way or
Of
the other.
course, for working professionals, time is a challenge. So we need to come up with flexible ways of making the resources available. And as Dr. Amod mentioned, it should be micro learning, small bites, so that even if I get a few minutes, I should be able to go back, read something. It should be accessible from my phone. It should be in small bites. All that would actually help a lot. Sure.
Right, right. Dr. Amod, I have one last question for you. And I know for a fact that companies like Mahindra and Tata and the big companies, they are very institutionalized and they have these programs to upskill and reskill their own workforce. But this industry is also, there are so many startups that have come in and we don't really know the nature of them. They're so new and thankfully they're all young. So they are reasonably skilled. But as they get old, we don't know how they are going to function. What is your understanding that are you engaging with these startups as well, or have they reached out to you saying that we need to hire people or we have people in our workforce who need to be skilled in some specific way? Are they also as adaptive to change as companies like Mahindra or Tata or any of the other companies are?
Oh yes, startups are definitely very open to understanding how they can get a way to increase their growth rate, right? And ultimately, the things that startups focus most on is how do they accelerate their trajectory and become a major player in the industry in any new space. And we talked to a number of the startups today in the EV community, and the common requirement across all of them really is the ability to bring in a systems thinking to electric vehicle design. How can someone go from say a requirement of 100 kilometers range to sizing the motor to then figuring out how you should what should be the PCB, and then what should be the software under that. This type of a look of the electric vehicle as a system of systems is a very critical skill that we hear a lot about. And once we are able to impart that type of a perspective, we see a strong appetite from the startups to hire such as engineers, even if they may not have the traditional degree that typically is expected for such jobs. So that's where I see a lot more flexibility from some of these younger companies.
Dr. Shankar, is Mahindra in touch with any of the outside third-party educational institutions, universities for the kind of reskilling that you were talking about, or is it largely done in-house?
It's a mix of both, actually. I would say there are a good number of courses which are designed and taught by our own product designers and practitioners. But we also collaborate with universities in India and abroad to design and teach many more courses. So it's always a mix of both that we do.
Okay. And so same question to Dr. Amod. When you plan a curriculum, uh, are you tempted to probably poach somebody from the industry, like raid Mahindra and get some designer in so that he can make the course for you, which will be relevant for the industry?
Yeah, great question, Sumant. That has been one of the unique aspects of Skill-Lync, that a vast majority of the material has been created by folks in the industry who want to then give back their learnings and knowledge. So we worked with over 1250 industry professionals over the course of developing 250 plus courses. And they've been able to bring a lot of their understanding from their day-to-day work into the different projects and challenges that we offer. And in that way, we've heard that a number of times, when students completing the course are talking to recruiters, many times a technical manager would say, "Hey, this looks, like what I would expect my team member to be doing after 3 years, and you've already done a project like this, even though you're a fresh graduate. How did you learn about this?" And that's where that strong connection to the industry has been a very helpful aspect of Skill-Lync, and not just in terms of contributing for curriculum, but we've also been able to bring on board a number of industry professionals with vast expertise in this industry into Skill-Lync to really contribute in a larger way to the technology.
Okay.
One particular example I would just like to talk about here is
Yes, please.
Mr. Pradeep Kelot. He used to be the head of engineering for Bosch India, leading their electrification efforts. And once he retired from there, he's now joined Skill-Lync as the principal architect for electric vehicles. And he's able to bring more than 30 years of experience in the industry into our curriculum and really help make that even more appropriate, not just for the graduating engineer, but for engineers throughout their early career in the industry, up to say 5 to 7 years of experience.
So, Dr. Shankar, at Mahindra, what are the kind of resources that you employ for this whole process of reskilling, and how much time does it take? So, for somebody who is, say, for example, on the shop floor making any particular suspension part or the whole assembly of the vehicle, and once you have to go into EV manufacturing, how much time does it take to adapt and to reskill and to learn, and then to finally go back into the shop floor?
Sure. So about few years back, we started with mapping the skills of every single engineer at the Mahindra Research Valley. And also we looked at the future skills they need to get onto newer technology spaces. So we created customized learning maps for every single engineer so that they know what all they need to learn to get onto these new roles. Then it's between them and their manager to figure out how fast they can do, whether they want to do it in 3 years or 2 years or 1 year. So the manager has the business priority in mind, and the individual has his own career growth priority in mind. So they both discuss and arrive at a plan. But the engineer is sufficiently empowered. He knows what the entire learning trajectory is like, what all he need to learn to get into those desired role. So that part we did it at a very early stage. And so each individual engineer has this map with them ready. So it becomes much, much easier for them to plan. And a lot of them actually stretch themselves to do extra courses because they know that once they do that, they'll be able to look for the next bigger role. And that's the strongest motivation. And we provide all resources. We have dedicated labs and workspaces to help them to just go ahead and do it beyond their regular ongoing project schedules. So that's what gives them the flexibility to do it at their own pace.
Right. Thank you, Dr. Shankar. I promise that I will let you go at 5:40. It's 5:43. I know you have another call to attend to, I think. Thank you so much for joining us at ETAuto EV Summit 2022. I look forward to interacting with you again very soon, whenever time permits.
Absolutely. Hey, thanks a lot, Sumant. And thanks, Dr. Amod. Good talking to you. Thanks a lot.
Thank
Thank
you.
you. Nice meeting you.